Okay, so here we are on number 27, and they're saying the blood platelet counts of a group of women have a bell-shaped distribution with mean 253.9, standard deviation 63.3. Use the empirical rule. Okay, what's the approximate percentage of women within 3 standard deviations? Now, what's the empirical rule? Let me go to a fresh place I can work here. So number 27, sorry, that's a little messy there. Number 27, the empirical rule is what? Well, it's basically that bell curve. And it says if this is the middle, so this is the middle, X bar, the average, the middle. And this is one SD, back one SD. So right one SD and back one. So within one standard deviation, in here is 68%. So within one standard deviation jump, back one and forward one, of the middle is 68% of all the data. And then if you go to here, this is 1, 2 plus 2 SD. This is 1, 2 minus 2 standard deviations. So from here to here is 95% of all data. And then the final thing, if you go out one more jump, so that's 1, 2, 3, back 3 standard deviations, or 1, 2, 3, forward 3. So from back 3 to forward 3, there's 99.7% of all the data is captured. If you can read that. Sorry, maybe I better erase this and say 99.7% of all the data is within 3 standard deviations of the middle. Is that making sense? So what we're saying is this is the middle right here. This is X bar, the average, right in the middle. So this could be shoe sizes, men's shoe sizes. This could be blood platelet counts. This could be IQ scores, whatever. There's some average, right? There's some average shoe size, average IQ, whatever. And then 68% of all people are within 1 jump right and 1 jump left, or I should say 1 jump right and 1 jump left, of the middle, 1 standard deviation jump forward or backward, 68% of the people. 95% of the people are within 2 jumps right and 2 jumps left of the middle, and 99.7% of all people are within 3 jumps right and 3 jumps left of the middle. That's the empirical rule. So let's go back here then. So when they say how many are within 3 standard deviations, it's automatically 99.7. I don't need to do anything with the numbers. Next question, part B. What percentage of women are within 190 are between 190.6 and 317.2? Well, if you take the middle, the 253.9, I bet that's this number, 300. It looks like it's that number added. It's 1 jumped right. So if you add the standard deviation to 63.3 on your calculator, you'll get 317.2. What does that mean? This is plus 1 standard deviation jump. That's 1 jump to the right, plus 1 SD. And the 190.6, that's 253.9 minus 63.3. That's just 1 jump to the left. So this one is back 1 standard deviation jump. So how much of the data is between back 1 jump and forward 1 jump? Well, remember, if you look back at the graph, that's 68%. So that's just a tricky way for them to give you numbers that are forward one jump, back one jump, so the answer is 68%. So you want to have on your 3x5 card for the exam this empirical curve here, the bell curve. It's called empirical rule. Also, well, we'll go back. Here it is. It's called the empirical rule, or the bell curve. Same thing, two different ways to say the same thing. Let's move on. Number 28, consider a value to be significantly low if the z-score is less than or equal to -2, or significantly high if it's greater than or equal to +2. You know what z-score is? Z-score equals number of SD, standard deviation, jumps, right or left. Right positive, left negative. That's what z-score is. So like if it connects to the bell-shaped curve. So this would be z plus 1. This would be z minus 1. Equals. This spot would be z equals plus 2. This spot would be z equals minus 2. Does that make sense? It's the number of jumps you are right or left of the middle. That's what z-score is. So when they tell me that a z-score bigger than +2, here's z-score +2, anything bigger than +2 or smaller than -2 is very extreme. Like if you're talking shoe sizes or IQs, those are people with really big feet or really small feet or really smart IQ or really not very smart IQ. So, extreme people, very high or very low, whenever you're more than 2 standard, remember standard is typical, you're more than twice the typical amount above or below. You're very extreme, high or low, when your z-score is more than +2 or less than -2. So let's go back. So on this one, when they say, that's what they're saying here, z-score less than -2 or greater than +2, you're significantly low or significantly high. Okay, so what's their question? A test here is used to assess college readiness. The mean, that's the middle, was 20.7. The standard jump, that's the typical amount people are off the middle, the standard deviation, was 4.9. Identify test scores that are significantly low or high. So basically, if you want to take to be, so which ones are low? Let's start with the low. Let me get rid of all this scribbling. So to answer the first question, what test scores are significantly low? To be low, you've got to take the middle, 20.7, minus 4.9 twice. Because that's 2, it's low, right? It's 2, I'm getting the 4.9 right here. It's the standard deviation. 2 standards below the middle. So take your calculator. I'm going to do mine. And subtract 4.9 twice from 20.7. And I'm getting 10.9. So basically, test scores that are, this answer B, that are less than 10.9 are significantly low. And now, part B down here, which ones are significantly high? Well, we take the middle, the 20.7, and we add the standard jump twice. Because if you're 2 jumps above the middle, you're extremely high. So that'd be 20.7 plus 4.9 twice. And I'm getting 30.5. So test scores that are greater than 30.5 are significantly high. All right, let's move on. Number 29. Okay, in a recent award ceremony, the age of the winner Best Actor was 34. Age of the winner for Best Actress was 50. For all Best Actors, the mean is 45.9. Standard deviation 5.6. Maybe I'll do the, here, let me try this again. Maybe I'll do the min in green. So 34, 45 is the 0.9 is the average, standard deviation 5.6. Then we have the same thing. So for the actor z-score, how do you figure out z-score? Z-score is the score they got minus the average over the standard deviation. So what's the score for the men? Let's do the men first, for the actors, not the actresses. The actors score, the person that won, the score in this case just means age, because we're just measuring age on this problem. So that would be 34 minus, what was the average? Mean, 45.9, over the standard deviation, 5.6. So what this will do, this will say how far was this average from, was this age from the average age? Well, it's, subtract on the top. I get 34 minus 45.9 minus 11.9, then divide by 5.6, and I'm getting Z is minus 2.125. What that means is that age, that person was younger, 34 years old, is younger than the average actor that wins Best Actor. He's younger by about 11.9 years, this 11.9 on the top. But then I divided that by 5.6. Why? Why am I dividing by 5.6? Because that's the standard deviation. That's the typical amount people are off the average. So I want to see he's 11.9 years younger, negative, younger, less than average. But how many? Divide that by 5.6, and you get negative 2.125. That means he's 2.125 jumps below the middle. He's more than 2 full jumps below 2 standard amounts. So he's way young, right? Because the jump is 5.6. The standard, the typical deviation jump from the middle is 5.6. He's more than 2 whole jumps below the middle. He's a very young actor. That's extremely young, because it's more than, anything more than 2, positive or negative, is extreme. Now let's do for actress. It'll be the same thing. I'll do it down here. For the actress, for the actress, z-score again is the score, in this case the age. She was 50, minus the average for the women, mean was 35.5, so the women were usually younger. I think that is usually how it goes in Hollywood. They love youth. And divide by 12.8. So let's see. Now she's older than the average. 50 minus 35.5 on my calculator, I'm getting 14.5. She's 14.5 years older than the average. Divide that by 12.8, because there's a lot. 12.8 is the standard jump, standard deviation. So she's only 1.13 older than average. It's positive because she's older, right? She's 1.13 jumps above the middle. She's 14.5 years older than average, but divide that by 12.8, which is the standard jump amount. She's just a little bit more than 1 whole jump above, positive, above average. Oh, I was supposed to round this other number, wasn't I, to 2 places? So looks like 2 minus 2.13, because they said round to 2 places. Okay. So who has the more extreme age? The actor has the more extreme age, because his numbers, z-score is more extreme. Anything more than 2 is considered extreme. The actress was a little older than average, but not crazy. Her z-score was only 1 point. She's only little more than 1 jump above the middle, above average. Whereas the actor, he's more than 2 full standard amounts below average. He's really young compared to average. Let's move on. Number 30. Use the following cell phone, find the percentile corresponding to 5.3. So where's 5.3? Right here. Percentile. Percentile. Remember what percentile means? Percent below. So to find the percent below, how many scores below? Remember, there's 10 scores in the first row, 10 in the second, 10 in the third. That's 30, and then this is score number 31 right there. So there's 31 scores below the 5.3 out of 50 scores total. So divide that on your calculator, and you get 0.62. Change that to a percentage. Remember, you move it twice. 62%. So 62% is the percentile. I don't think they want you to actually put the percent symbol here. Just 62 is the percentile of the score 5.3. That means if your cell phone has a data speed of 5.3, you're at the 62 percentile, which means 62% of all cell phones are below you. So you're above average, right? You're right here. 62% of all cell phones are below you. You're at the 62 percentile. That means percent below. Let's keep moving. 31. Q3. They want me to find Q3. What does that mean? Well, remember, it's like a football game or a basketball game. Q3 is the end of the third quarter. So what part of the way are you through the game at the end of the third quarter? You're 75%. Okay, so into the third quarter means you're 75% of the way through the game, right? Q3 means end of the third quarter. At the end of the third quarter of a football or basketball game, you're 75% of the way through the game. So that means what they really want is the 75% of the way through, which is P equals 75%, percentile. So they're asking you to find the 75th percentile. Now, how do you find percentiles? Well, we have a formula. The locator equals P over 100 times N. N is the total number of data values. N equals number of values. So L equals P, 75, right? Because we're trying to find Q3. The end of the third quarter means the P is 75. Put that in right there, because at the end of the third quarter, you're 75% of the way through the game, times N. How many total data values do we have here? It's 50. So that's 50. So then multiply that on your calculator. 75 divided by 100. And I get 37.5. 75 divided by 100 times 50, 37.5. Now remember what we do with this. In fact, let me go out here and write this down. So finding percentile. How do you do it? Step 1, locator is P over 100 times N. That's what we just did. And then step 2, if L is a decimal, round up, or I did an example, like 7.2, round up to 8, and grab 8th data value in the list. Step 3, if L is whole number meaning not a decimal, like L equals 12, then grab 12th and 13th. The next one. You always grab that data value and the next data value and average them. So there's the game plan for how you find a percentile. You start with the L, it stands for locator, because it's helping you locate the right data value. And then you calculate LP over 100 times N. If that comes out a decimal, like 7.2, round it up to 8, grab the 8th data value. So let's go back. So we got 37.5 decimal, rounded up, 38. So I want to get the 38th. So my 38's not my answer. It's just a pointer to my answer. I'm supposed to grab the 38th data value in the list. So where's the 38th data value? Well, there is 10 data values here, 10 there, 10 there. So that's 30. So this is 31, 32, right? The first three rows have 10. So 10, 20, 30, 31, 32, 33, 34, 35, 36, 37, 38. That's the 38th data value, 10.1. There we go. See how that works? You find the locator, p over 100 times n, came out 37.5. If it's a decimal, you round it up and then go find that data value, the 38th data value, which was 10.1. So this L thing is always a locator telling you where to go in the list to find the data value. Let's do number 32. 32 asks for the P20. So how do you do that? The locator is p over 100 times n. So that's 20. You put the 20 in right there. 20 over 100 times n. What's n? Again, 50. There's 50 data values. If you calculate that, you'll get, I think it's 10, won't you? Yeah. Okay, now that's a whole number. So L equals 10, whole number, not a decimal. What do you do? Let's go back. What do you do if L is a whole number, not a decimal like 12? Then grab the 12th and the next one, the 13th. Whatever whole number you get, you grab that spot and the next spot. So if you get a 12, you grab the 12th and 13th, and you average them. So let's go back. So we're going to take 10th and 11th and average them. So what's the 10th data value up in this list? Remember, there's 10 numbers per row. So this is the 10th number, and this is the 11th number, isn't it? Right? This is the 10th number. This is the 11th number. So you take 0.6 plus 0.6 and divide by 2. You average. That's how you average two things. Add them and divide by 2. You get 1.2 divided by 2, which is just 0.6. So 0.6 is the 20th percentile, the P20. That number, 0.6, is 20% of the way through the data, right? It's 1/5 of the way through the data set. Let's go on to 33. 33. 14 different second-year medical students at a hospital measured the blood pressure of the same person. The systolic readings are listed below. You use the given data to make a box plot and identify the 5-number summary. What do? So basically you take these and you just put them all into your calculator, and it will give you the 5 numbers. Okay, so you put all those numbers into your L1 list. You hit on the TI calculator, you hit the stat button, and you you clear out your old list 1, go up to L, move the cursor up to L1, hit clear, and then put in all this data, and then hit the stat button again, and it'll crank out all these numbers. You got to push the down arrow to get these numbers. And so basically, here's what I got. I got 120, 125, 134, 140, and 150. Those were the 5-number summary. And then that turns into a box plot. How does it turn into a box plot? Well, basically, we're going to have a big number line here, and the box is going to go like this, and this will go down to the 120. This line will be at the 125. This line will be at the 134. See how this is second number, first number, third number. This line will be, the right edge of the box is the 140, and then the whisker up here to 150. Some people call this a box and whiskers diagram. You have these whiskers going up to the max and the min. Basically, this is the minimum value, the lowest value in that whole data set. This is the Q1, the Q2, the right edge of the box is Q3, and this is the maximum value in the whole data set. Basically, it breaks all the data into 4 even sections, like a football game or basketball game, 4 even sections. 1/4 of all the data values are between 120 and 125. The next quarter between 125 and 134. The third quarter of all data values are between 134 and 140. And the top quarter of all data values between 140 and 150. So which of those, A, B, C, or D, box plots, you can just look for the left edge of the box. Which of them have a left edge at 125? This one's left edge is somewhere past 130. No way. Look at let's see. Let me see. These are looking kind of close, aren't they? Hey, I just realized the answer they want is C. They've made a mistake on this problem. They didn't do it right. The left edge here is supposed to be right there at 125 because that's 125. They messed up. The box should be right there. And the 134 should be the middle part. That looks good right here. That looks like it's about 134. They did that right. The right edge is supposed to be 140. That should be right here. They messed up on the box. The lower whisker is supposed to go down to 120. They did that correctly. The upper whisker up to 150. They did that correctly. They messed up on this problem. The answer's C. So there we go. There's the last question. Hope that helps.